Welcome back, guys. All right, so moving through in our Math 31 curve sketching unit over here. Topic we're doing is called intervals of increase and decrease. So what we mean for intervals and decrease is if you look at a function from, let's say, left to right. Okay, if function goes up, f is increasing, goes down, f is decreasing. Okay, so as you look at a function from left to right, if the function is going up, it's an increasing function. If it's going left, if it's going down, it's a decreasing function. Okay, so hopefully here, so I'm going to say f is increasing on, and I'm going to use interval notation for this. Okay, now hopefully you see that from here to here, the function is getting bigger. Okay, so it's going to be from negative infinity to negative 2. Okay, now we're not going to include negative 2 because so at negative 2, the function is completely, it's got a horizontal tangent over here. That means the function is going to be neither increasing nor decreasing here. And then also from, when we look at here from x equals 0 going this way, is also getting bigger. Okay, so it goes from negative infinity to negative 2, and then from 0 to infinity. We look at the decreasing parts. F is decreasing on negative 2 to 0. Okay, so from here to here, the function is starting to get smaller from there. Okay, so just looking at this graph over here, this is how we tell. Now, the way we apply the stuff we learned in calculus over here, okay, if we look at a function that is increasing, and I look at the tangent line, say I look at the tangent line at this point over here, hopefully you see that the tangent line is positive, it's sloping upwards. Okay, if we look at a function where it is decreasing, say here, and I draw the tangent line like this line is sloping downwards, therefore the tangent is negative. Okay, now how do we measure slopes of tangents? Well, we do that with derivatives. Okay, so for part 6 over here, this is algebraically determine the intervals of increase and decrease for this function here. So what we want to do is we want to take the derivative of this function, so f prime of x equals 3x squared plus 6x. Derivative of the negative 4 just goes to 0. Okay, and now the idea is if f prime of x is greater than 0, then f is increasing. So this is saying if the slope is positive, which the derivative measures slopes, if it's positive, that means the function is increasing. If f prime of x is less than 0, then f is decreasing. All right, so we need to kind of go back and think for, well, if I want to figure out when the function is increasing, so I want to figure out when is this guy greater than 0. So in other words, when is 3x squared plus 6x, where is this guy greater than 0? Now, the way we did this, if you remember back to Math 20, we did something we called a number line analysis. Okay, so and we did that by, first of all, I want to figure out what the zeros of this inequality is. So 3x, I can factor out a common factor of 3x, and you're left with x plus 2. So my zeros are 0 and negative 2. And if I put these guys on a number line, here's negative 2, and here is 0. Okay, now we call this a number line analysis because we've now separated this number line into 3 sections. Numbers less than negative 2, in between negative 2 and 0, and then numbers bigger than 0. Okay, well, I want to figure out if I take a number over here, we can take a test point, say negative 3. I want to figure out, is this region going to be positive or negative? So if I take a negative 3, 3 times negative 3 is a negative number. Negative 3 plus 2 is negative 1, which is a negative number. A negative times a negative is going to be a positive number over here. If I take a one in this case over here, say negative 1, 3 times negative 1 is negative. Negative 1 plus 2 is positive. A negative times a positive is negative. If I take a number bigger than 0, I get positive, positive, positive. Okay? All right. So in this case, well, what this number line analysis has done is tells us is in this interval here and this interval here, our derivative is positive, and means the function is going to be increasing. So I'm going to say f of x is increasing on negative 2 to 0, union with 0 to infinity. F of x is decreasing on negative 2 to 0. Remember, guys, this is interval notation over here, right? So we're saying that this is the lower bound, this is the upper bound. The round brackets means we're not including the boundary points. Guys, I made a mistake here. F is increasing on negative infinity to negative 2. There we go. This is better. So negative infinity to negative 2, and then from 0 to infinity. And it's decreasing on negative 2 to 0. Okay, so that's how these guys work with the number line analysis here. So strategies for this: you want to take the derivative, set the derivative, and then kind of factor derivative to figure out what the zeros are. Put those zeros onto a number line, and then do a number line analysis on this. All right, similar question over here. We have this function. We want to figure out what the intervals of increase and decrease are. So y prime equals, the 3 comes down, cancel with this. It's going to be x squared minus 5x plus 6. So solve this inequality, figure out where this guy is positive. It's going to be x minus 3, x minus 2. Okay, so we're just going to factor this quadratic over here. And we want to figure out a 2 and a 3. And now let's do our number line analysis. If I take a number less than 2, I get a negative times a negative, which is positive. Say 2.5 is going to be a negative times a positive, which is negative. Say 4 is positive, positive, which is positive. F is increasing on negative infinity to 2, union with 3 to infinity. F is decreasing on the interval from 2 to 3. Okay? All right, moving along, guys. It's going to get a little bit more difficult. We have a degree 4 one over here, but same steps. We want to take the derivative. Okay, now let's factor this guy. Common factor of 4x, and left with x squared minus 1. Difference of squares. Okay, our number line, we're going to put on a negative 1, 0, 1. Let's test each interval over here. If I take a negative 2 in this one, I get negative times a negative times a negative is negative in this region. Negative 0.5 would be negative. Positive, negative is positive in this region. As positive 0.5 will be positive, positive, negative. Number bigger than 1, positive, 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 is positive in this region here. So our function g is increasing on negative 1 to 0 and from 1 to infinity. It's going to be in this region here and this region over here, where it's positive here. G is decreasing on negative infinity to negative 1, and then from 0 to 1 like this. Okay, so there's going to be our answer for this guy over here. All right, guys, hope that makes sense. Okay, let's kind of summarize this. If f prime of x is greater than 0, then f is increasing. If f prime of x is less than 0, then f is decreasing. Okay, so strategy for intervals of increase and decrease, we take the derivative, figure out our zeros, and then we kind of set them up on a number line and do a number line analysis to determine if each interval is positive or negative. All right, guys, see you in the next video.